In this video, we're going to be explaining problems 11 through 15 on the AMC 10A. So here they are. Problem number 11. A square of area 2 is inscribed in a circle of area 3, creating four congruent triangles as shown below. What is the ratio of the shorter leg to the longer leg in the shaded right triangle? So this has area 2. This bigger thing has area 3, so each of these triangles have area 1/4. So 1/4, 1/4, and 1/4. So this is A and this is B. Then A plus B is equal to square root 3 because that's the side length of the larger one, and this is A. And then AB is equal to 1/4 times 2, which is 1/2. Therefore, A and B are roots of the quadratic polynomial 2x squared minus 2 root 3x plus 1 is equal to 0. Solving, we get x is square root 3 plus or minus the square root of 12 minus 8 over 4, which is end up being square root 3 plus or minus 1 over 2. And therefore, our answer becomes square root 3 minus 1. We want to find the ratio of the shorter leg to the larger leg. So over square root 3 plus 1. Simplifying radicals, we end up getting square root 3 minus 1 squared over 2, which is 2 minus square root 3. Answer C. Problem 12. How many 3-digit positive integers n satisfy these properties? So we have these. So first, the number formed by reversing the digits of n is divisible by 5. If the first digit is 0, that won't work because then it will be 3 digits. So it must be 5. And now we must have n is divisible by 7. So that means that we must find the number of numbers that are 3 digits that start with 5 and are divisible by 7. So, and the numbers are 504 and all the way to 595. And that's 72 times 7. That is 85 times 7. And therefore, our answer is 85 minus 72 plus 1 is 14. And that gives answer B. Problem number 13. Abdul and Chiang are standing 48 feet apart in a field. Bharat is standing in the same field as far as Abdul as possible, so that the angle formed by his lines of sight to Abdul and Chiang measures 60 degrees. What is the square of the distance between Abdul and Bharat? So if this is Abdul, this is Chiang, and this is Bharat, then we have this angle ABC is 60 degrees. And that means that B lies on a fixed circle. So let me go ahead and draw that fixed circle in. So sorry if that's a bad circle. So let me go ahead and draw a better one. There we go. So that's A, B, and C. And in order to maximize the distance between A and B, we want A and B to be diametrically opposite on the circumcircle. So AB is a diameter, and angle ACB is 90 degrees, which means we have a nice 30, 60, 90 degree triangle. So and this is 48, so that's 96 over root 3, and our answer is 96 squared over 3, which is answer C. It's 3072. And problem number 14. A number is chosen at random from among the first 100 positive integers, and a positive integer divisor of that number is chosen at random. What is the probability that the chosen divisor is divisible by 11? And so 91 of the numbers from 1 to 100 are not divisible by 11. So that's 91 over 100 times 0. And then the other 9 out of the 100 are divisible by 11. And are of the form 11k, where k is not divisible by 11. Now, every single number is either divisible by 11 in the factor, either has a factor of 11 or it doesn't. So that means that half of them have 11, half of them don't. So we multiply this by 1/2, we get our answer 9 over 200. Answer choice B. Problem number 15. An even number of circles are nested, starting with a radius of 1 and increasing by 1 each time, all sharing a common point. The region between every other circle is shaded, starting with the region inside the circle of radius 2, but outside the circle of radius 1. An example showing 8 circles is displayed below. What is the least number of circles needed to make the total shaded area at least 2023 pi? So let n equal 2k. That's the total number of circles. And for k equals 1, ends up being 3 pi here. This ends up being 7 pi, 11 pi because it's 36 minus 25, and 15 pi. So this case here, k equals 4 is shown. And in general, when we increase k by 1, we increase the total area in the next layer by 4 pi. So our answer is 3 pi plus 7 pi plus all the way to plus 4k minus 1 pi, so that there are k regions. Using the arithmetic series formula, this ends up being k times 2k plus 1 pi, and we want this to equal 2023 pi. If we multiply both sides by 2, we end up getting n times n plus 1 and we want this to be at least. So that ends up being 4046. And so now we look at the answer choices. N equals 60 is way too small because 60 times 61 is less than 4,000. And that means that all the other choices are too small. And that leaves E as the only option. And indeed, 64 squared is greater than 4,046. So our answer is E. So thank you so much for watching this rapid fire of the AMC 10A problems 11 through 15.